Okay. Hello, everyone. Welcome to our presentation, Navigating the Data Storm from Data Lake on AWS to Databricks. Let me introduce myself. My name is Jacek Cieslak. I'm a service manager in Raiffeisen Tech. And today I will tell you a little bit about our platform's journey from old Data Lake to Databricks. And as for my colleagues, Mateusz and Robert, Robert will tell you a little bit about the need for self-service on AWS, and Mateusz will tell you about how the need of the data engineering perspective, and also the challenges that occurred during the data migration. So, how those started? We used to have an old data lake that was fully on AWS. This was an EMR solution, and with a sprinkle of Airflow for scheduling, and S3 for data layer. But as you know, with time and data growth, the issues start presenting themselves. And basically, we started to notice that this solution wasn't sufficient for us, and in long term would be difficult to manage. This was due to lack in data sharing, and basically in enabling projects for accessing the data. You can imagine there was a lot of requests regarding this, and with time, when you have a lot of projects, a lot of databases, shares, requests, basically we get more and more problems regarding this. When you have hundreds of databases, shares, cross-shares, and I can tell you that AWS has a lot of constraints. This was basically bottlenecking us and slowing us down. And as the platform grows, everybody wants to have everything working smoothly on it, but it's always difficult when stuff is growing. So we needed a better solution, something that would basically alleviate our stress and provide better governance and better control, a one platform to rule them all, let's say. This white horse on the night, and basically we chose Databricks, and after a little time we also decided to migrate our data. And with a little bit of time also, we noticed multiple benefits, like the governance of data management, as well as we have also enhanced collaboration tools, as well as resources utilization, like better control when users start to play with the clusters. So this was quite useful for us, as well as enhanced security. As you know, we are a bank, so we need it everywhere. And also, we had a unified data platform at last. This was our goal at the beginning and desired need. And also advanced analytic capabilities, as well as real-time data processing. But as you know, we had additional problems with, like I mentioned before, with data sharing, with databases. Projects were coming more and more with the requests, and we were unable to satisfy them as fast as they were requesting. So we needed a better solution, a tool that could provide self-service for data management, basically creation of databases, shares, cross shares, enabling projects to do that basically on their own. And like I wanted to mention, rapid data creation, also cross-sharing in unified fashion, as well as the group-wide data access, because when you have a huge organization, getting data from different countries is quite difficult, and going through all the processes, requesting approvals, etc., can be delaying everything for everyone. But I think for more information regarding this, a better person will be Robert. So let me pass this to him. Thank you very much.
Thank you, Jacek. So my name is Robert, my surname is Marek. Polish native speaker probably know why I have this specific habit of telling which one is which. And for non-native Polish speakers, you can ask your Polish colleagues as a small talk opener. Okay, so I'm DevOps at Raiffeisen Tech, and I'm here to tell you a story of tragedy that never was. So, we are engineers, right? We love technology. That's good, that's our trade. This is why we are paid so handsomely to be a little obsessed about technology and new solutions, right? But because of that, sometimes we lose the wider image, wider horizon on the whole of the project. So imagine this scenario. We delivered a platform. It's new, shiny toy that will be used by our much smarter colleagues from the data engineering team and data science team. They will create so beautiful models and so absolutely awesome data processing tools that will provide our organization so much money. I already see it, right? I'm so happy. I see in my imagination a rise that is coming. Team is also very satisfied. We worked so hard on it. I have 3 kittens. They are not the smartest creatures on this earth. They have commonly, they share 4 brain cells, but even they are very happy about the situation. They see that I'm happy, which means that they will probably get a lot of very tasty salmon treats. So we are right about our platform. We are onboarding more and more data engineers and data scientists on our platform. We are moving from old ways to the new ways. Everything is fine, right? Right? So, as I said, they are very smart people, and there is a thing about very smart people. They don't like cookie-cutter solutions. Because they are pushing boundaries, they really don't like boundaries, which is kind of obvious, right? So, because of that, they usually, when they are creating this boundary-pushing new solutions, they want to change a little bit about the default template, which means a lot of Jira ticket to us just to change a little bit the solution that they were provided with. Just a little bit. But this a little bit is really making a big pile, which makes me worried because I know that the workload is really not doable to our team, which also make our team a little bit stressed out, a little bit. And also, as I said, my kittens are not very smart, but even with these 4 communal brain cells, they understand that the salmon treats are probably not coming. But fortunately, this is a strategy that never was. This is a scenario that never happened because we implemented self-service, what it means in our context. So the idea is not really that difficult. It's basically delegating some of this reconfiguration, some of this personalization of the workspaces to the end users. So amongst our very smart colleagues from data science and data engineering teams, we are selecting the most responsible ones to be basically workspace admin, so they could personalize the subsystems of the whole platform. So yeah, So that sounds great, right? But how they would do it, right? Because it's not the best idea to give them just admin rights. They need tools. And for the tools, we are implementing microservices. Everyone loves them, and as we all know, it's so easy to implement microservices that there are no problem at all. Of course not. A small remark, isn't it kind of strange that the microservice paradigm exists for so long and we still don't have like a single solution for that? I mean, one must imagine the corporate Sisyphus happy, I guess. So yeah, so we started implementing the microservices. Basically, every microservice is responsible for single subsystem in the platform. And for that, we implemented multiple microservices, but let's dive deeper into one of them. One of the most difficult ones, so maybe the technical difficulties are something to tell story about. So, data service. Data service is used for management of the sharing data inside of the organization, basically. And as for the stack, let's start with the stack. We are using the AKS cluster on AWS, and on that, we are creating the Django pod, which communicates with RDS instance, which basically keeps the configuration of the whole, basically metadata of the whole solution, of the whole data in the organization, more or less. We also have Celery, which is used for scheduling tasks, more on that later. And we have Redis, which is used here absolutely in different way than usually, because it's here we are basically using it as temporary memory for the Celery. So yeah, we need scheduler. Why? Why is that? We have a small problem because basically our migration to the new platform is not so straightforward. Was not so straightforward. Due to technical difficulties, the data sharing is a little complicated topic. And for that, and because of that, the data sharing is multi-stage process, which is not really, it's kind of time consuming, especially some steps. So we cannot provide immediate answer when end user is calling API. We need to have something to organize the whole process, return to the end user future, basically the future endpoint for the results. And in the meantime, we need to implement somehow the actual process. So for that, well-known and liked solution command chain. So basically, we are dividing the whole process, end of the process, all of them, into the smallest possible subtasks, which are implemented separately. For each of the tasks, we are also implementing the rollback. So when the end user is calling out the request to some of the endpoints inside of the data service, the chain is created with all the bundled tasks, and each one is consecutively executed. And if something wrong happens, for some reason, which is quite often, the rollback triggers, and we start rolling back until we reach the initial state before the request. So, kind of easy to understand solution, I guess. But even with that, you may imagine there could be problems, especially with the when we try to access the same resource with multiple tasks, because we have multiple users that can, of course, try to reach the same endpoint. And in case of our organization, actually, even if they are not trying to access explicitly the same resource, quite often the sharing of data requires implicitly modifying some resources that could really collide. So for that, we also have simple solution. Simple actually in quotation marks, because idea is simple, but implementation was not. And it is basically implementing specific semaphore for the resources and tasks. So we implemented the smart resource managers and task managers, which are keeping everything in line and making sure that if some resource is modified, other task cannot modify the same resource. In such case, the task is rescheduled and tried at the later time. So yeah, so these were just two small problems alongside of many inside of the whole package. This was only one of the microservices, so you can imagine that there were and there will be a lot more problems. But I hope that this showed you a little bit of wider image. Okay, so I told a little bit about self-service and the implementation, but I think it's time to show the data engineering perspective, and I think Mateusz will be the best person to show that.
Thank you. Hello, my name is Mateusz. I am a data engineer at Raiffeisen Tech in one of the compliance teams. And today I am going to show you a bit more of a data engineer's perspective on Databricks. I'm going to share a bit of insights and experiences on working with both AWS DataLake and Databricks. I would like to share a bit about the most interesting features that we have used in Databricks and how to deal with data quality. So a bit more about one of the use cases that we were working on in the following months. So while AWS DataLake is complex, it gives you a lot of possibilities. It also can get a bit exhausting because either you start provisioning all of your infrastructure or all of the permissions, you have to think about all the DevOps things as a data engineer, or you have to wait for the actual DevOps team to set your infrastructure. This becomes less and less productive. While with Databricks, everything seems to be in one place. Everything seems to be easily accessible. So for data engineers, it's improved our efficiency. And yeah, so there are three features I would like to talk about today. And I think the most interesting is data life tables or DLT. And quickly before I start talking about the solution in details, I'm pretty sure that everyone knows what a medallion architecture is, but for those who don't, just a quick recap. So it is a paradigm for processing data, and it consists of three layers or steps. So it's bronze layer for all the raw files, which are unprocessed. Then you have a silver layer, which consists of data that is a bit more curated, a bit more cleaned. And then you have a gold zone, which has all of the business aggregations and is also a source for all the business intelligence reports, AI, and data sharing. So why it is important? Because DLT stands with medallion architecture. And one of the things that it provides is automation. So with DLT, you don't really have to worry about how the data is going to be loaded, when, because DLT provides you a single wrapper around your transformations. So the only thing you care about is your Spark code, which does the processing of the data. But how it is getting loaded, it's on Databricks. Also, Databricks uses autoloader for ingesting all of your files. So it enhances your experience and makes it available to load data from different sources and gives you a lot of possibilities regarding to the timing of data arrivals. both SQL and Python can be supported with DLT, which is great for teams for larger teams where maybe not everyone is comfortable with writing in Python or not everyone is comfortable with SQL. You can do both, which is maybe not a big thing, but a really nice touch. And data quality utilities, and they turned out to be really important especially for us. So with DLT, Databricks introduces expectations, which are utilities for data quality, and they allow you to set the expectations regarding your columns. So they work really similarly to constraints in databases, just a bit more complex. So of course you can set up your expectations to be column not null or no duplicates allowed, but you can also set the range of the data that you can have or the length. And what is fantastic about this is that every row that doesn't meet your expectations is going to get flagged in a log file, so you always can come back to it. But it's not all yet, because apart from the fact that it is going to be noted, you can choose or configure your DLT, its behavior when you have such bad records. So I'm pretty sure that there are use cases when it makes sense to just fail a pipeline or the whole update, which is possible. You can just log it into one of the tables, because you can create shadow copies of your target tables, and they will contain only the bad quality data, which might be useful for further analysis if you feel like you need to do some more analytics and understand why you are getting the bad data. And you have a schema evolution, so you don't really have to worry about new columns popping in, breaking your whole pipeline, or some of them suddenly disappearing, which happens to all of us probably. And different load types support. So depending on your use case, you either can trigger your pipeline periodically, or you can set it to be continuous so that DLT is always up and waiting for new files to be processed at the second that they appear in the S3 or whatever. And also there is a support for streaming-based pipelines, so you can connect it with your Kafka or Apache Pulsar in our case, and this seems to work fine as well. And yeah, DLT is a pretty great feature that has been introduced, and it connects pretty well with Databricks workflows. So I'm pretty sure all of you already know about Airflow or Dagster. Databricks implemented their own scheduler, so it is being used as a task orchestrator, and it keeps all of your dependencies managed so that your data products are being processed in the correct order. There is a support from Cron-based schedules, which seems to be a standard at the moment. And also you have multiple task types. So any kind of resource that you could create in Databricks is able to be launched with Databricks workflows. So it can be DLT or any, let's say, jar package or Python wheel. And recently, I think you even can refresh your data dashboards. Sorry. So it's complex and fits the need for scheduler. And honestly, I couldn't think of anything more that I would need from a scheduler. And also, it provides you with integration with Slack, Teams, emails, or webhooks if you need to incorporate it into your applications. So you are always aware that there is a problem with your processing or that it already finished. And the last one that I would like to show you is alerts. And they are really simple. a solution, but really helpful as well, at least in the use case that I'm going to show you in a few seconds. So they are a SQL-based, this is a SQL-based solution. What you need to do is to create a query which returns only one value. Then you can use this value and compare it to your threshold, and then you can run it periodically. So either you can check your KPIs, which are super important, every hour, or you can check how much delayed is your data. So it's essentially a scheduled query, which then sends the information to you. The configuration is simple, as I said. You just need to create a query, then attach it, and you create a schedule. So sounds pretty simple. And there's multiple target destinations. So the ones that I showed with workflows will also work with Databricks alerts. And super interesting is that the body of the alert is also adjustable. So you can provide the links to the documentation or to anything related to the topic of your alert, and it is going to be sent out as well. And all of this is to bring you to one of the situations or case studies that we have had last few months. So the idea is pretty typical. We have a new data product that is going to be super necessary. We do have a set of complex data transformations that need to take place. The business logic is pretty complicated because we are going to connect the data from different sources. So yeah, sounds like a regular data product, but here comes the two issues. One is that the data delivery is super irregular. Another thing is that the data quality is really poor as well. We source data from multiple units, and we do not have at the moment unified approach to data quality control. So each of the units can have their own. They are not being controlled at the moment, or they were not controlled at that moment. So what do we do about it? Using Databricks, we created a solution consisting of all of the three features that I've just shown you. So we do have DLT for data processing. So we use Spark, we create bronze, silver, gold layers, and so on. Everything is processed, all the transformations are being done there. We also use expectations. So as I said, we create the shadow copies of all of the tables that are getting created for the purpose of further analysis. And this analysis is a last step, which is called data quality checks. We created a Python wheel, which takes all of the shadow copies, shadow tables, and does some aggregations and measures what types of data quality issues we have, how often they occur, and we get more insights about this to be able to say what is typical, and we can take this to the providers of the data and consult this with them. Alerts were used for monitoring data, so we could have like 7 days of the delay, and it doesn't make really sense to run the pipeline every day if we already know that nothing is going to be processed. So we set up the alerts to monitor one of the tables that said about the data delivery, and only if it was if it was triggered, we would start the processing. And for the orchestration, we used workflows, which seem to be a great solution for that. And yes, this is the time for questions. So if you have any, please let us know.
Okay, we have the first question. Let me take this one.
Thank you. Very interesting, very enlightening. I'm curious how much of the work as a data engineer how much of your time gets consumed by resolving these data quality issues and addressing them. Because if you have the brown zone and bronze zone, and then you need to build the pipelines, and the pipelines break, you have state in one and the other, and so on. So how much of the work of data engineers is spent on addressing the data quality issues, and how much is spent building features and like doing the actual analysis?
Initially, a lot. A lot of our time would be consumed on analyzing what issues we do have and why do we have them. And we have noticed that this is an issue. And this is why we created a data quality checks package. So it's kind of one. It fits our needs for data processing and analyzing the quality. And because it is highly configurable, we don't really have to spend a lot of time on analyzing it at the moment. It is being standardized. So at the beginning, we spent a lot of time trying to tweak the data quality and understand what's happening. At the moment, not so much. Usually once a week, someone will have a look at the dashboard with data quality issues, and we'll speak to providers if there are any issues.
Yes, so how long was the process of, and how much influence you had over, you reported an issue, and then people accountable started fixing the root cause, right? So how long was the process of getting from we know that there are many issues to today?
A lot of time has come, and while it's still not ideal, because to fix all of the data quality issues, you have to go back one step back. So at the moment, the biggest problem is that someone needs to fix the systems that provide the quality, which is bad data. So it is up to the design of or the architecture of a solution, how easy it is to fix it. But yeah, the conversations have already started. So yeah, between spotting an error and initial plans for fixing, it's quite fast. Then it depends on how complicated the system is.
I saw a question here.
Hey, I'm just wondering what was the biggest challenge from the technical perspective in using DLT? I mean, what you can consider as a disadvantage of DLT after this project?
I think that the biggest issue with DLT is that the syntax can be quite tricky. We spent seriously a lot of time trying to understand all of the wrappers around DLTs and the order of execution. So I think this is the biggest problem. Yeah, does that answer your question?
Questions?
Hi, Marcin Kuć, Asana. My team is currently working on a migration Databricks. I would like to know what were the biggest mistakes you've made on your journey to Databricks and what you learned from them.
Okay, that's quite interesting question. So the biggest challenge and the biggest mistake, I would say many architects and users of AWS Cloud know that policies can be quite a tricky thing, right? So I would say because we are sharing the data cross-region, cross-account, and so on, it was surprisingly challenging to create a solution to fit all of these needs inside of a single platform, basically. And I cannot tell the details, but quite often the policies and I actually have one specific thing. So because we are dependent on the policies, and as you may know, there is a limit of the policies, we found a problem that when some specific dataset is very popular and we need to share it with a lot of end users in the different accounts, we actually had a problem with the limitation of the policies. So yeah, so I would say the most challenging were making all the policies fit into our needs, because we needed to create actually the specialized library to optimize all of the policies. So we had specialized system to optimize policies to use the least amount of characters possible and to basically optimize between the statements. So because we have both limitation of the maximum size of the policy and amount of policies. So our specialized library is actually optimizing that to achieve the most. So yeah.
Okay, any last question? Okay, the rest please take offline.
Thank you very much for very refreshing and covering a fundamental elements talk. I have a question related to data engineering part. So I am not expert in Databricks and DLT solution and so on, but I am wondering about one thing. What about the testing and I mean testing for CI/CD?
So for CI/CD, we have adopted, first for infrastructure as a code, we use Databricks asset bundles, which is a already baked in solution. It's essentially a wrapper around Terraform because all the logs are still from Terraform. And with this, we use GitHub Actions. And one of the most important things that we have learned regarding CI/CD is that service principals are extremely useful for that, because if you don't use them, then all of the resources are created by your user, and when you leave the company, they are getting destroyed as well. So that was one thing. Regarding the testing of the pipelines, we have not still found a perfect solution yet. DLT is built around notebooks. So for notebooks, it's not so easy to test it. However, if we have non-DLT packages, we create some wheels and already have baked-in testing.
Yeah. Okay. Thank you. Because one more thing. You mentioned that resources are created by a specific user. I think that you can use a WordPress client and
Yes, or
example?
service principals, then you have them attached. Yeah.
Thank you.
All right, it's time to give people the applause. Thank you.
Thank you very much.